Hello friends, this is the solution of cloud computing Sppu Endsem examination May 2022. Okay, so this was the paper of May 2022 of 70 marks end semester. So we'll go through each of these questions. So question number 1A, define virtualization, explain types of virtualization. Okay, so as you know, virtualization is the process of creating a virtual version of something, that is hardware or storage or network. So it allows multiple operating systems and applications to run on single physical machine. So it is important that single physical machine you can create multiple virtual machines, enhancing the why we create virtualization to enhance resources and flexibility. So it is asked types of virtualization, and for 8 marks. So there are multiple types of virtualization. First one is hardware virtualization. In hardware virtualization we create virtual machine. There are two types: full virtualization, para virtualization. These are the two main types. Hardware assisted examples are VMware, ESXi, Microsoft Hyper-V. These are the that is hardware virtualization. The second one is operating system virtualization. Multiple operating system instances on the same hardware. So on same hardware you can install Ubuntu, you can install Fedora, you can install Windows. So this is called as operating system virtualization. It uses containers. So OS virtualization uses containers. Docker and LXC, these are the two examples. Third one is virtualization of servers. So partition physical server into multiple virtual servers. Each server can run its own operating system. Resource management, it is for better resource management. Next is storage virtualization. It combines multiple physical storage units into one logical unit to enhance performance and redundancy. SAN and NAS, these are the two examples. Next one is network virtualization. It creates virtual network over physical network. In network there are switches, routers and firewalls, so all of them can be virtualized. Next one is application virtualization. So an application can also be virtualized, which is run on server, we can run on end user its virtual copy. So Citrix, VMware, ThinApp, these are the application virtualization. Next question 1B, discuss virtualization in grid and virtualization in cloud. So in other words, comparison of virtualization of grid and cloud. So in grid we focus on sharing of resources. Virtualization is used for job scheduling, load balancing in the grid, heterogeneous environment for, and it is also compute intensive tasks. Okay, this was about grid. In cloud, what we focus on? We focus on the service models like infrastructure as service, platform as service, or software as service. Cloud is mostly used for scalability and resource usage. Okay, automation and provides abstraction. These are the differentiation points. In grid, the distributed systems are the resource type. In cloud, centralized data centers are used. Scalability of grid is moderate, but scalability of cloud is high. Abstraction level is job or task level, but here entire virtual machine is an abstraction. In grid virtualization, scientific tasks can be performed. In cloud virtualization, you can have businesses and consumer services over the cloud. So these are the two parameters, these are the two categories we can differentiate on. Differentiate between, next question is 2A, differentiate between full and para virtualization. Okay, so full virtualization is emulated on hardware to run modified operating system. In para virtualization, guest operating systems are modified, okay, for better performance. So here hardware virtualization is there, here OS virtualization is there. Guest OS modification not required because it is hardware virtualization. Here obviously it is OS virtualization, so it is required guest OS modification. Performance of full virtualization is low because of overhead of hardware virtualization. In para virtualization, performance is better. Hypervisor role, here full abstraction is given in full virtualization. In para virtualization, the API for guest OS are given by the hypervisor. The examples of full virtualization are VMware Workstation, VirtualBox. In para virtualization, Xen with modified XL Linux kernel. Okay, so Xen is the example of para virtualization. CPU instructions handling, here binary translation is used in full virtualization. In para virtualization, instructions are non-virtualizable. OS support in full virtualization can run on any OS. In para virtualization, the limited operating systems are supported. Okay. In para virtualization, the overhead is low. In full virtualization, overhead is high. Next question is functionality of hypervisor, and type 1 and type 2 hypervisor we have to describe. Okay. So answer is hypervisor. You already know it is a virtual machine monitor which handles the hardware and virtualization. So it creates and runs virtual machines. So it allows multiple operating system to share single hardware host. So in figure you can see there is single hardware. Hypervisor makes possible virtualization. So this is VM. Okay, so virtualization is made possible by the hypervisor. So there are some types of hypervisor. Type 1 and type 2 hypervisor. Type 1 hypervisor is called as bare metal hypervisor, which is installed on directly hardware. Type 2 is hosted hypervisor. Okay, so look at the type 1 hypervisor. Directly on hardware you can see hypervisor and then multiple virtual machines are there. So this is one VM, this is VM2. Okay. In other words, on the other hand, the type 2 hypervisor are hosted hypervisor, where on hardware you need one operating system, and using this operating system you can create virtual machine. Okay, so this is VM1 and this is VM2. Obviously each of these virtual machines will have its own operating system, but basically before installing this hosted hardware you need this operating system. Here no need of operating system, so it is bare metal, it is hosted. Okay. Functions of hypervisor you already know. It allocates the resources, ensures isolation between virtual machines, enables hardware abstraction. Type 1 runs directly on physical hardware, offers better performance. These are the examples. Hyper-V, Zeno. In hosted hypervisor runs on top of the host operating system, set up with high overhead. Oracle VirtualBox, VMware. This is the example. Next is question 3a. Explain different services offered by Amazon Web Services, that is AWS. So how many different services are there AWS? So you can write 8 different services for 8 marks. Okay. So the most popular service is compute service, that EC2, Amazon EC2. Scalable virtual servers are used. Lambda is also there, serverless computing. Storage service, there is Amazon S3, that is simple storage service, and EBS, that is elastic block storage. Third is database service, that is Amazon RDS, that is relational databases, managed relational databases, right? Amazon DynamoDB, it is NoSQL database. Fourth one is networking service. So AWS provides you VPC, that is virtual private cloud, and Route 53, that is scalable DNS service. Next is security service. For security, IAM, that is identity and access management. KMS, that is key management service, this is for security. Then next is application service, that is SQS, simple queue service, and SNS, that is simple notification service, this is for application. So this gives you the messaging queue, and this is the push notification. So the push notification that we get on our different applications, like product delivery application or food delivery application, this service is used, SNS. Next is monitoring service, that is CloudWatch and CloudTrail. These answers are sufficient. Then next question is discuss Amazon Dynamo database service. Okay. So Dynamo, here we have seen Dynamo is a database service, right? So database service DynamoDB. So the next question is for DynamoDB. So it is fully managed NoSQL database service designed for high availability, low latency, and scalability. Key features: NoSQL structure, managed service, high performance, scalability is very high. It is used tables. It uses table, that is container for data. Row of data is item. Attributes column. Primary key is used, and secondary indices are also used. It can be used for gaming, e-commerce, and real-time bidding platforms. The example of DynamoDB, where you can see that key value pair is used, user ID, name, and purchase history. So these are the examples. Next question is Microsoft Azure platform. You have to explain this. So Azure is a Microsoft cloud platform offering wide range of services like computing, analytics, storage and networking. Okay, so in computing we have these services: Azure Virtual Machine, Azure App Service and Azure Functions. In storage, blob storage, disk storage and queue storage. In databases, Azure provides you Azure SQL database, Cosmos DB. In networking, virtual network are provided and Azure CDN, that is content delivery networks, are there. Next is AI ML service of Azure, that is Azure provides tools like Azure Machine Learning and Cognitive Services. Next is DevOps integration provided by Azure, CI CD pipeline, Azure DevOps and GitHub. Management tools like Azure Portal, Azure CLI and PowerShell. High availability given by Azure, global reach, scalability is also high, pay as you go, integrated with Microsoft tools. Right. Next question is the features of Google App Engine. This is also asked for 9 marks. Okay. So Google App Engine is a platform as a service provided by the Google Cloud for developers to build and deploy applications. So you can build your own applications using Google App Engine, just like your Play Store, right? So what are the features? Fully managed environment, scaling, everything is good, load balancing. Which languages are supported? Java, Python, Go, PHP, Node.js, .NET and Ruby. Built-in services, it provides the database services like NoSQL database, task queue, cron, jobs, etc. Automatic scaling, it is scaled automatically. Integrated versioning, that is it supports the deploying multiple versions. Security is given IAM, easy deployment. These are the some use cases like App Engine for backend logic, Google Data Store and Google Map. This all use the all created by Google App Engine. Next question 5A, cloud security service with its this question is repeated many times. Security of cloud. Why we need security of cloud? Because the cloud is adopted very fast. Data security becomes critical. Security services like integrity, confidentiality, compliance and availability in the cloud is necessary, right? These all services are necessary. So cloud, that is most important service is identity and access management. Who can access the resource and why, what they can do on is what their role. Role based service, AWS IAM and Azure AD, these are the two services. Data encryption services are needed for the cloud, so AES encryption, RSA, then Azure Key Vault and AWS KMS, these are the security services. Firewall and perimeter security prevents unauthorized access, includes security groups. Okay, so examples are Azure NSG, AWS WAF, right? Security information and event management, real-time monitoring and analysis of security alerts are needed for the cloud. Threat detection and compliance, Azure Sentinel is used for the security information and event management in cloud. Intrusion detection, the suspicious activity we have to detect, signature based systems are used for that. Backup and disaster recovery, business continuity, for business continuity backup is needed. Regular snapshots of your data and geo redundant storage is also important. Compliance and governance tools, these are used for the regulatory policies, AWS config and Azure policy, these are the tools. Next question is cloud computing, risks in cloud computing and how you can manage them. Okay, this is also asked for 9 marks. Okay, so the different risks are there, that is data breach, unauthorized access, mitigation of strong encryption, access controls are needed. Data loss, if data loss is there, accidental deletion or system failure, so mitigation, regular backup, redundancy is needed, disaster recovery is needed. Account hijacking, so stolen credentials can lead to misuse of your account. Solution is multi-factor authentication, IAM best practices. Insecure APIs, so exposed APIs can be exploited, so you can secure them using authentication and rate limiting, that is the time you can give, that is session, etc. Okay, denial of service, flooding your server with multiple requests, that is called as denial of service. Solution is load balancing, auto scaling, firewall rules and captcha also you can use here, right, to detect if it is human, it is robot or human. Malicious insiders, so So employees can or contractors can the access to these services. So you can have least privilege access and activity monitoring. Next is compliance violations. So failing to meet the regulatory requirements, vendor lock-in. All these are the risks. Okay, now mitigation also we have seen. Next question is security authorization challenges. What are the different challenges in cloud security? Multi-tenancy environment. So cloud has multiple users. So this is also security challenge. Dynamic resource scaling. Scaling is frequently scale up and scale down. So this is a challenge. Distributed architecture. Cloud has spread across regions and multiple clouds. So centralized authorship is difficult. Lack of standardization, no uniform way of implementing access control. Then granular access control, fine-grained policies required for this. Federated identity management, that is also the challenge, that authenticate from multiple identity providers. Delegated authorization, that is temporarily grant rights, this is also challenge. Audit and visibility is needed for this cloud security analysis, right? So these are some solutions: role-based access control, attribute-based authentic 2.0, SAML. All these are the security solutions, right? Next question: how do we need to perform secure software testing, cloud software testing? Okay, so testing cloud applications involve verifying both functional and security aspects. What you can test in cloud security: threat modeling. You can test that how your cloud reacts to the attacks on SQL injection, data leakage. Then static application security testing, that is SAST, that is needed for vulnerability detection. These are some tools which can be utilized for that. Dynamic application security testing, these are used for testing the application running state. Penetration testing for ethical hacking. Cloud configuration assessment to check the misconfigured storage buckets. Okay, all these are the testing tools, okay, for the security of cloud. Security logging and monitoring testing, data protection testing, compliance testing. Okay, so this was the sixth question. Now seventh question is aware energy aware cloud computing with suitable example. Okay, so energy aware computing aims to optimize the energy consumption in data centers and cloud infrastructures. Okay, so SLA standards we need to obey. So why it is important? Data centers consume huge electricity, high energy usage, so we have to reduce that. Okay, so techniques are that dynamic voltage and frequency scaling. Then next is virtual machine consolidation, energy efficient scheduling, cooling optimization, and use of renewable energy like solar, wind, and hydro. All these are the environmental factors that we can use for the energy aware cloud computing. Okay, so the examples are given. A cloud provider uses machine learning to predict workload pattern during off-peak hours. It consolidates VMs to fewer physical servers and power them to idle machines, saving energy. Okay, that can also be one solution. So carbon emission should be reduced. This is the aim. Next is, with example, we have to explain Docker. So Docker is open source platform designed to automate the deployment, scaling, and management of applications of containers. Okay, container is a lightweight standalone executable unit that includes everything needed to run a piece of software. Okay, so it's just like API. Okay, code, runtime, libraries, everything is there in a container. So container is most specifically used in the case of cloud Docker. Okay. Unlike virtual machine, containers share the host operating system's kernel but remain isolated from one another. Docker builds the cloud effectively utilize the containerization technology, scalability, and orchestration. It integrates the cloud tools, that is Kubernetes, with automated deployment. Right. DevOps integration. This is also needed by providing the tools for continuous integration. This is the figure which shows you the architecture of this Docker. Like Docker, the image, the containers, registry, which are used for the source code. From source code, it is going to build the image, tag and registry, full image, and Docker. Right. So these are the this is the architecture of Docker. Then last question, question 8: cloud and IoT together. How they to work. Okay, so cloud computing offers storage, processing, and management for the IoT application. So cloud plus IoT creates smart, connected, and remotely controllable home automation. So you have to explain home automation, right? So it works IoT and cloud. Sensors and devices in the home. IoT devices like smart bulbs, like lights, camera, and thermostats we can use. Devices may include motion sensor, door locks, and light switches. So Wi-Fi, Zigbee, and cellular for 4G, 5G you can use. For storage, you can use analyzer behavior, make intelligent decisions. Remote monitoring, you can have the commands from the app. Automation from AI. Well, this is the scenario. Like motion sensor detects the movement of the person. Sensor sends data to the cloud. Cloud runs if the motion is detected. It's dark, and it's dark. Then turn the light on. Cloud sends the command to the smart bulb and smart bulb automatically switch on. This is a simple example which can be used for the automated home automation system. Arduino, you can use Raspberry Pi, you can use MQTT, these are the protocols, HTTP, Wi-Fi, Zigbee. Cloud services, AWS IoT, Google IoT, and Azure IoT, any you can use. Alexa, Google Home, and smart things you can use. Differentiate, last question, between cloud computing and edge computing, right? So these are some points. Cloud computing, these are the services that cloud provides on distributed environment across multiple physical locations. In edge, we use the processing occurs at near data centers, not in a central cloud. Right? Location in cloud it is across multiple, but in edge the location is nearby, right? In close proximity. Latency moderate in the cloud, very low in edge. Example that is Google Distributed Service, AWS, and Azure are the cloud. Green grass of AWS Edge, Azure IoT Edge, Cisco Edge, Fog Fabric, all these are the Edge examples. Use cases that is the examples, focus, compliance focus, real time. All these are the points you can read and get them. Hope you got the solution of this cloud computing Endsem paper which was asked in May 2022. Next paper we will discuss in the next video. Thank you all. Hope you understood this point.